Yo, how's everyone doing? This is going to be somewhat chill stream. I'm just trying to get familiar with what I was even doing. So, yeah. Oh, thanks, dude. Appreciate that. Yeah, sorry. I've been on hiatus for a little bit. Work's been crazy. Feel like I can't really use that as an excuse since it's been like, I don't know, intermittently years between when I like post videos, but I don't know. I started a new job recently, and so it's tough trying to do projects outside of work too, while you're trying to prove that you're worth hiring at a new company. I don't know. It's kind of difficult to do outside projects with that going on. But I don't know. I've worked at this new company for 3 years now. I feel like I have a good handle on things, and I feel comfortable starting to make this a regular thing. So here's the plan. This is what I'm going to do. It's really difficult to set up scripts for the videos and then do all the editing. It's not something that I necessarily have a whole bunch of time for, nor is it something that I really enjoy. So what I think I'm going to do going forward is I'm going to do a lot of live streams, and then eventually I'll curate some of the live streams into videos that I make into the videos that you're used to seeing for RoboDog. So a little bit more curated, maybe have an editor splice things together and stuff. Live streams, it's a different beast because you're recording potentially for hours and hours at a time. So someone, either me or someone else, needs to go through that footage and clip out the good parts, which takes time. So I'll figure it out. But if I'm doing work on the side for the RoboDog project, I feel like some of that content that I'm not even showing in the videos might be useful to people, and they can also ask questions and engage. So yeah, I feel like that's probably a good way to go for it. Some content rather than no content. Also, this is like the first time that I'm like streaming in this sort of setup. There's a lot of things that have changed in this office. I actually recently, I obtained a mill, so that's fun. I'll probably have some videos on that. That thing weighed 400 pounds. Don't ask me how we got it in this room. It's crazy. We didn't have a lift either to lift that thing. We lifted it manually. So I had a buddy come over and kind of positioned it. But yeah, I'm just glad it got on that stand in one piece. So yeah, I'm definitely it's weird because I'm a mechanical engineering major, but I know far more software, slightly more electrical than I do mechanical. So watching me do milling videos on that is not probably going to be as instructive. It's going to be mostly me learning, but I do plan to do that eventually. I think that'd be cool. For the RoboDog project, I kind of got it for the RoboDog project. I wanted to be able to build enclosures for some of the electronics. So this is a good opportunity to do that like in-house. Yeah, I know. This is, you know, a combination of mechanical, electrical software, right? I have my electrical bench behind me. What I have in front of me is like a software station with dual monitors. And mechanical to my left. Oh yeah, and a music studio to the right. It's a crazy room right now. Just adding on to it. But like, I realized for the longest time, like one of the things that kind of held me back from doing projects was like, I've been sort of neglecting cleaning up the office and like making it into a more productive environment. And psychologically that did something that like kind of made me not want to work on stuff too. So after I took a break from work, like I literally took, I think 2 weeks off, a good 2 weeks off. I didn't travel anywhere. All I did was just clean the garage and clean the house. And that made me want to do more projects like this. So it's interesting how just having a clean slate and cleaning off everything makes you want to be more productive. Okay, so let's get into it. Let's go to the hopefully interesting part, not boring part, but I don't know. It's coding, so we'll see where it goes. So lab bench, let's do, oh yeah, also, this is interesting. I mapped keys on this keyboard to screens, like views that you guys see. So if I wanted to see lab bench, right, I just hit a key and you guys see the lab bench. Or if I want to go back, you see this. Or if you want to see screen, right, go over there. So it's mapping MIDI keys, MIDI signals to scenes in OBS Studio that I'm using. So I thought that was interesting to go back and forth quickly. And this is also going to be interesting because I don't have a, like my software screen is over here while I'm going to be messing around with electronics over here. So I don't know, we'll see how this goes. I think what I need to do is I need to bring my, so things are gonna go wrong with the hoverboard motors over there, and I can't initiate a sequence for the hoverboard motors to go while I'm over here, because if shit hits the fan, I want to be over there to protect stuff. So I'm gonna move this keyboard. I'm gonna move my setup over here. We'll see how this works. I had to buy some extra long cables for this. Also need to show another thing too, which is, I'll show it in a second after I connect this. Okay. So another thing that I've been working on, I've showed it in some of the videos. I'm gonna move you guys. So here is a mini server rack that I've been working on. These are various circuit boards that I work on, whether that be for work or for hobby. And I put the Zybo board in there. And the Zybo board is the main control unit for RoboDog. Let's turn it on. Let's see what, I think I have this connected. Yeah, I put LEDs in there. That's nice. There's I forget what the name of the fan is called, but it's supposed to be one of the quietest fans that you can possibly get. Should be able to turn it on back here. Where is it? There's like a speed controller that I have. There we go. Yeah. Can you hear that? Because you shouldn't. Okay. All right, so I have this USB. I know there's like a lot going on here. I even need to remember what I'm doing here. So I have a switch that's connected to my main internet. And this should be connected to the Zybo board, so I should be able to SSH into this. I have a USB going to this USB hub down here, and that connects to all the boards, although none of the boards are powered on except for the Zybo. Actually, I need to flip the Zybo board on. So I think if I get a good view here. Is this switch to Zybo? I don't know, I turned on something. Oh, I turned on the switch. Okay. And I think maybe this one's the Zybo. Turn on. Yep. Okay. Cool. You see the lights come on. All right. So here's the deal. That Zybo board is connected to this USB hub, and that USB hub is connected to my computer back there. But that computer back there is just being projected on here. Or at least one of the monitors are. So I'm gonna try to code on this while I'm over here so that if anything goes wrong with this, I can kind of protect what's happening. In addition to this USB hub, the Zybo board has, you notice that there's two USBs back there. So in addition to acting as like one of those USBs that I can like use for communicating through UART, this USB is like the computer USB. So like it can access peripherals through there, like a host versus an OTG, if you're familiar with those. And this USB is connected to this hub up here. So in other words, like I want to communicate to this Zybo board with my computer, hence that's what that USB is. And this USB is connected to other peripherals that I want the Zybo board to have access to. What USBs, you may ask? What is it connected to? These two are connected to one of it is the webcam up here, and the other is the O drive motor controller. So I can send commands to the O drive from that Zybo board, and I can also view image processing stuff too. So this is going to be kind of hard to capture all of this. I don't have enough webcams, but I'll try my best. So, question from chat. Mohammed, I have a question. Do you think DIY channels like yours can break even, or are you even treating it just like a hobby? I want to start mine, but I know I required intensive investment. Yeah. I'm actually not getting paid for any of this. This is just a hobby. Like, like to be able to stream or do enough requirements for the YouTube monetization policy, you have to have at least 1,000 subscribers, and I don't know, like, what was it? 1,000, 4,000 watch hours? 1,000? I don't know. I'm not keeping track of it. I'm not super interested in it. I'm not getting paid, like I said, so. But I think it's possible. I think if you wanted to make this something that you monetize, it's probably best if you also go with Twitch. in addition to YouTube, because I've seen people stream to both. You guys can't see my screen. Let me, oh yeah, I can use my keyboard. It's this one. There you go. But that's not, oh, I need to map the other one. Oh, this is gonna get confusing. So this one is, I want you guys to see that one. Yeah, it's tough to build a following. I mean, it definitely helped doing mechatronics and stuff, and meeting connections personally that way. But I think it's a lot easier to build a following on Twitch, and then you can also stream to YouTube. YouTube's a better foundation for storing your videos. Twitch isn't that great for storing videos, but it's great for interacting with the community. But like you said, it's a large investment. So, all right. So let's see. Let me zoom in here. Okay. So what you guys are looking at right now is just a workspace. I actually have all of this code uploaded. I do repo status, I can see what I was doing. Like, all of this stuff is code I was doing almost a year ago. It sucks that I didn't commit it because I don't know what shape it's in now. I'm waiting for the rest of this to load. It's taking a while because I'm using Yocto, or I used Yocto back then, and like, as you know, if you've seen any of the, like my last live stream, I was showing how to make an operating system from scratch. I was using Yocto for Raspberry Pi. This is Yocto that I used for building the Zybo board operating system. So I have this on right now. So actually, let me open up another tab. I'll zoom in here. And let's just try to get into the Zybo board. Let's see, how would I do that? I need to remember, see how good my memory is. 10. Oh, I might have to. I might have to go into serial to see what the IP address is. I think, let's see if this is still the same COM port. Nope. I can check device manager to see the COM port of the Zybo board because it's on right now. I should be able to view it. Just to guess, it might be 5. Yeah, I think it was 5. Yep. Okay, cool. I'm in. You know, this is tiny. I don't know if I can zoom in putty, but it doesn't matter. I just need to get the IP address. This is not Windows. This is Linux. 90.19. Okay. This is connected via internet. It should be 192. No, it's 10. Okay, that's why. There it is. All right, so now I'm SSH'd into RoboDog, and this is what's on there now. So again, just to clarify, when I say RoboDog, that is the Zybo board up there. And that Zybo board is connected to that O drive, which is a motor controller to control these motors. So I think what my goal for this video is going to be is I want to just move this. I want to use image processing because I actually So I don't know, can you guys see this? Let me see. It's kind of far. Let me bring you guys a little bit closer to see what we're working with here. So this hoverboard motor has a laser that's on top, and I can turn this laser on. I took apart like a laser pointer for looking at like whiteboards or like just normal pointing on a screen, right? Like there's buttons to move along a slide deck. I didn't need it, so I took it apart and I actually soldered a connection inside. Let me see if I can turn this. I soldered a connection inside. Oh, you can kind of see it. It's that piece right there. I cut a piece of metal and I shorted the laser to the on switch. The on switch being this switch on the side. Because I hated the fact that if I turn this on, right? So I'll turn it on right now. It still has batteries. So it's on, but before you had to push a button. You had to push this button to turn this laser on. Now I just shorted that. So whenever I turn on the laser pointer, this just stays on permanently, which is what I want, because this is good for figuring out what angle this motor sits at. So when I turn it, I'll kind of know where this is pointing to. And this is also a mechanism that I'm using in image processing. Like I don't track onto the laser with this webcam. I'm just using the laser to understand where this last hoverboard motor is pointing to make sure that it aligns with what I think it should. So if I'm like tracking an object, right? I want that pointer to point to that object, so that I know that my image processing algorithms are working the way that I expect it to. So I'll keep that on. Maybe I should turn it off for now, just for the battery. But I'll turn it on once I start moving stuff around. But that's my goal, is to just move stuff around again and get to a point where I can like maybe hold something in front of the webcam and have the laser track onto it. Have you changed the, so this is a comment. Sorry if I butcher your name. Michelle? Mishari? Sorry. Hi, have you changed Hall sensors in the motors for better ones? I ended up drafting or drilling a shaft of a hoverboard motor and put their thin rod with a magnet for encoder at the end. Yeah, actually, I do plan, so I haven't changed it yet. In past videos, I know that I learned that the Hall sensors were not very good for the resolution for these motors. If you want to do any sort of precise movement with hoverboard motors, you kind of need to ditch the Hall sensors. And so one of my goals is to, I think it is in here, right? Where did I put it? Yeah, it's right here. One of my goals was to not swap, but maybe the Hall sensors are still going to be in the motor, but I'm going to have, I'm going to try to get these encoders feeding into the O drive as opposed to the Hall effect encoders, the Hall sensor encoders. The Hall encoders are built into hoverboards, in case anybody doesn't know. So as you move along, right, you're detecting how many pulses are going on and off. It's just not a very good resolution, not really good for robotics applications. Also, it's not absolute. So you don't know exactly what angle you're at when you turn on the system. These are absolute, so you know exactly when you turn it on. What I'm concerned about though is if there's going to be magnetic interference, because these hoverboard motors are pretty beefy. So I don't want this to turn and then that interfere with the absolute encoder readings of this chip. But that's part of this project, is just to figure out if that will even work. We'll see. I haven't gotten there yet. I'll definitely do it in one of these live streams though. And that's another reason why I got the mill behind me, so that I can make enclosures and position it in a good location so that there's not, or to minimize interference. So we're in the RoboDog right now. I think, if I remember correctly, the machine vision server is something that I run. So this is like, it works with WebSockets. I think if I turn this on, okay. So right now what's happening is that there's a server that I created in Python that is running on the Zybo board right now, and it's waiting for a connection from a client. And that client could be this tab, where, let's go to where this project was. So that's machine vision client. Let's just do like a Vim into this, just so that we have like a good working session here. We can edit code if we need to. So this is the code here. I'm going to open up a terminal. Turn this down a little bit. Okay. So let's just see if we can connect to the client side. I'm hesitating because I want to make sure if I run this, the motors are not going to freak out. Let me close this real quick and see what mode this is in. Machine vision server. I think usually with code yeah, okay. With code that I involve with motors or anything that can move, I usually have like a statement at the top saying not to use motors, or like an ability to turn it off, right? If I just want to test things. So I have that off. So I should be okay. If I run this right now, the image processing should turn on, and I shouldn't have to worry about the motors freaking out. Let's look over here. What is this doing? Oh, I might have to enable. Oh, okay. There it is. Nice. So this is what the RoboDog is saying. This is from its perspective, or will be its perspective. Let's see if I have something to track onto. Let me, I have a good object up here. So this is pretty good for tracking, just because it's green. And so how I program this is you click and drag a box of what you want to track, you let go, and it tracks onto it. It's pretty decent. The window's kind of big. Let me shrink it a little bit so you can see the sliders on the bottom. These sliders are to control it further. Let me get a wider window here. And I can so that's funny. It's tracking the, I have LEDs, green LEDs over there, so it's tracking those too. So, but because those are smaller, I can erode those away and then dilate what's remaining in the picture to give it a really nice track. Let's erode some of the other pixels away. Yeah, so this is pretty good. Depending on the shade that I'm in, let me get a better track. Let's see. Yeah, this is a tough environment because I have a lot of different lightings going on. Like there's a light right under the lab bench. Let's see. Okay, so this is on the client side. In other words, this is on my like desktop computer. And this is on the Zybo board. This is on the RoboDog. There's actually, so, you know, these are this queue before correction, after correction. Yeah, I'm trying to remember what I was doing. Initial error. Okay. I think this is, okay, so these queues are, I think, angular displacements of where the joints are. And the initial error and new error, I think it's where the robot's trying to go to based on the image processing. Let's go back to this design over here. I'll kill the image processing here. So escape. The nice thing about this is like how I program this is even if you kill the client side, the Zybo board is still going, and that's intentional because you know you want to use the client initially to configure the image processing, and then you want to remove the client, and then the robot autonomously would go off, and you can potentially go untethered or not connected at all, and then it would still do its thing, and then you can just Control C to end it. But before I do that though, so this is still running. I remember I wrote another program called Live 3D Plot to make sense of where the robot thinks things are in the universe. And I should be able to just run that, hopefully. Maybe. Oh, okay, there it is. Oh, okay. I think, all right, I'm starting to remember. The reason why this is not moving, yeah, I have to have machine vision client up because that's what's getting the socket data information. And then I pipe that to a file, and then Live 3D Plot is picking that up. So let's close that. Let's start machine vision client again. And then I need to open up another tab so I can run that. I'll just view everything right now. I'll zoom in. Where was I? Workspace, dev, machine vision, yeah. I'll open up another one here. Actually, I don't need to open that. All I need to do is run machine vision client. Or sorry, no, not that. I needed to run the Live 3D. Now I have two instances open. It's not what I wanted. Okay, there we go. So I'll open up Live 3D. That should work without anything running. It's just going to be stagnant, right? There's nothing going on. This is matplotlib. So I'll put this over to the side. I'll go over here. That's Zybo. Let's move this over here. Actually, let's move the Zybo all the way to the left. And then let's open up machine vision client. Make this a little bit bigger. There we go. And then let's open up Live 3D plotting. Yeah, it's kind of moving. You see that? These are so tiny. Come on. Not zoom in, I should be able to. I just double click. Oh, come on, don't be difficult. There it goes. So annoying. Okay. I need to do something about that white space on the side. I'll do that later. Can I like zoom into this? Zoom, zoom, zoom this way. I think it only zooms into the, yeah, that's annoying. All right. But you see this moving. That's because, okay, so a little lay of the land, I guess. Can I pan? I can pan, right? Oh, that is not pan. Oh, pan is here. Yeah, okay. Okay, so what you're looking at here is I had to do some inverse kinematics to figure out where's the range that this robot could potentially reach if I were to like have like a leg or like something extending out from the second joint of this. This is kind of just like a placeholder for now, but like this is some rough inverse kinematics, and then the shaded part here is just a it's a representation of where the robot can reach with its end effector, given the fixed length of the end effector that I gave it. The base, so you can see the camera here. I know it's kind of obscured, kind of tiny here, but the camera here is like the origin. You can see the motor 0 and motor 1. So camera, that's camera. Motor 0 is right here, and the motor 1 is here. Do I actually do feedback? No, it's only, yeah. So it doesn't go from the encoders to this simulation. It's more like what the image processing is telling the motors where to go. So that's what this is representing. So if I hold this up and I track onto this, you can see what the image processing is trying to tell the robot where to go. And if it does that, this is what the end result should be. Like go out further. Yeah, okay, that's what the target is. The target is the actual target, like what I'm trying to find. And then the end effector target is, oh no, wait. I think that's just end effector. They're overlaid with each other. So what I had to do was like, I had to do some math to figure out like if target was projected on the maximum reach of where the robot could go, this is what it would be. And that's what I'm trying to aim for. It turns out if I tell the inverse kinematics algorithms that I developed the location of the actual target, it messes everything up and just you get really wonky results. So unfortunately, you have to do this sort of projection where you project the target onto what is actually permissible or reachable by the robot with your link lengths, how long each limb is, and then feed that into the algorithms, into the inverse kinematics of where to go. If that doesn't make sense, don't worry about it. I'll probably have another video, or it's for another video for sure, to go into inverse kinematics. It's like a whole field, forward and inverse kinematics, how you decide where you want to go, what your joint angles need to be based on where the target is, and vice versa. But yeah, I'm just trying to remember what I was doing. So this seems pretty decent. I feel like, what if I bring it close? That seems accurate. Like this is what I'm telling the motors what to do. And I think that should be okay, hopefully. So I think I'm gonna turn on the motors and hopefully I don't break anything. Yeah. These motors are very powerful, so let's see. What's the best way to do this? I'll keep this live plot open because we can view that as the motors are actually going. I'm just, what's the best way to do this? Maybe, I think I can view the whole thing like this. So it thinks the target's right there when it's viewing the entire image. And that motor configuration looks fine. Like the motor should be able to do that without freaking out. So I'm going to turn on the motors with that. So I'm going to kill this client session. I'm going to go back over to the Zybo board, stop this, and just so that I don't have to like go to the file system of the RoboDog, I'm going to set something up here. This is what I had going before because I remember this Zybo FS. There's nothing in here right now, but there's actually a way to mount the file system that's on the Zybo board to my local desktop here. So that's what I'm going to do. So this Zybo file system, right? It's going to be populated here in a second. So what the information I need to be able to do that is what's the current directory that I want to map? It's in home root. And then it's like I think it's an SSHFS command. Let me see. Let's ask our friend. Do this. SSHFS, how to map remote file system to local. I just want the command, just the command, SSHFS. Okay, that looks right. It's root, and then I think that was the IP. And then the directory that I want to mount was in home root. And where I want to mount it to is this location. Yeah. Oh, that's a comma. Is it a comma? Oh, it just looks like a comma on my. Okay, I think that should work. All right, what's in here now? Zybo. Cool, all right, so now this is what is on the Zybo board, which is nice because now I can go into it for here and change it here. So let's turn this to true. And if we look on the Zybo board now and do head machine vision server, so just look at the first part of it. Oh, that's not enough. All right, let's actually look at it. This should be the true. Okay, all right, cool. So I can just pay attention to this. I still need to run it through here though. So let's run machine vision server. So once this starts up, the motors are going to move. All right. And if I remember, I needed to set an initial location. So this is like temporary right now. But if I hold it here and I start the program, this is where the coordinate 0, 0 is going to be. This is where its angle is going to start thinking it is. So this would be like 0 angular displacement for motor 1 and 0 angular displacement for motor 2. Let's turn on the laser. Oh, yeah, I probably need to turn this on. Let's turn on turn on O drive. exciting stuff. Are you ready to see everything blow up? Before I turn this on, let's see what the power's at. See my lights flicker? This is, it takes a very large voltage. Let's see, O drive. Should take up to 56, but let's set it there. Or let's do 24 for now. Okay. Power should be going into here. So it's going into O drive. It's going into both of these. All right, I haven't turned this on in like a year, so. Can't remember if the 0 angular displacement is when I start the, I think it's when I start the program and not when I turn on the O drive. I'm pretty sure. So, okay. Just to rehearse, if something goes bad, I need to shut off the power very quickly. All right. Well, I did that preemptively. Well, all right, let's try again. It's on. Okay, I feel it moving. Up. That wasn't good. What did it do? Let's try again. There's no attribute controller. I don't know what error that is. You're not going? Oh, maybe it's because I turned it off while. Can I do Control D? Just not happy. Do I have to turn off Zybo and turn it back on? I might have to do that. I wonder if I just like turn it on. Goes back. Control C out. No. Okay, cool. I'm gonna turn off the Zybo board. I think that was the third one. No, it's this one. All right. Turn it off, turn it back on. So this session will be dead. So let's close out of it. Let's open a new one. Zoom in. Give it a couple seconds to boot. Probably good enough. Okay. So let's go into machine. I don't need this temporary file. Because I probably reset the board, the file system is probably not available anymore. So let's remount it. There it is. Still set to true, right? Yep. Okay. Let's try this again. I'm gonna turn this on. Let's bring up, so this is where it thinks it's gonna go. Let's start this and see what happens. Looking for O drive. Oh, I know what happened. I know what happened. I think my power supply is limiting the current. So I need to have it not do that. Okay, let's stop this and then let's start it again. So I just raised the current limit on my power supply. That's it. Okay. Thought it normally takes, I feel something here. No? Okay, let's go to, do I have it running already? No, it's just alive, right? Yeah. Okay. Let's go to, so power supply's on, it's at 24 volts. I'm gonna start the client. I think this is when it initiates it. Oh no, it's off. Okay. I'm wondering, okay, I think what is happening is O drive, because there's a current limit on the power supply, O drive has some protection features where it noticed that it didn't receive the proper current and it still stayed on. I think I need to turn everything off and then turn it back on. I could see these errors if I probed O drive and looked at the register table and see what errors there were, but I'm pretty sure that's what it was. So I'm going to turn off this. Yeah, this killed because I stopped the machine vision server on the Zybo board. Yeah, because of this. Should be a way to like not be held up here, like Control D, Control C. Shouldn't have to reboot the Zybo board. That's kind of, oh, Control Z? Ah, that's what it was. Okay. Jobs, and then I can kill number 1. Yeah, all right. Okay. All right, so O drive is off. I'm gonna turn O drive back on. The current limit is set to much higher than it was. I'm gonna kill this client session because machine vision server should start first. So let's turn on power supply. It's 24 volts. Turn on machine vision server. Okay, I definitely feel the O drive taking. Yep, there it is. Okay, so it's moving by itself right now. And the reason why it's moving by itself, I'm going to start the client. It's just beating itself into submission. Okay, calm down, calm down. Okay. Zoom in here. Okay, and now let's look at the live feed of where it thinks it is, or what it thinks it's doing. This looks pretty accurate in this live, this simulation here. So the motors are basically that, right? So it's like, I can zoom in a little bit. Oh, that's pan. Come on. It's like pilot controls. Everything are like reversed. Let me zoom in. Okay. Motors are, you know, this is like slightly, so this is slightly shifted. This is slightly shifted that way from where I started it, which was like here. So this is now here, right? Which is what that is showing. And the laser started going at me, and now it's slightly tilted up, which is what you see in the screen. Which seems good. It's better than what I remember leaving the state of this in. Okay, so now let's do the real thing and let's track onto this and see what happens. So the reason why it thinks it's there is because the target it thinks is in the center here. So that's where the end effector is, right? That's where it thinks it is. Let me zoom out a little bit in this. Yeah, so it thinks the end effector is right here because this circle is showing where it thinks it's tracking. So if I start tracking this, and I can see the laser being pointed up. So as soon as I let go of this cursor, it should snap to this, hopefully, or it's gonna freak out. Oh, I might be covering it. You guys see that? Yeah, you kind of see it. Maybe I should give you guys a different view. It's kind of working. I wish I had a third hand. I can't really, well. So you kind of see it. You see the laser there. It's kind of pointing at this. It's not super accurate, but then again, like my placement on this isn't super accurate. Sort of cheating moving this. This is somewhat accurate. Like if I move this up, it should start going up a little bit. Let me get a better track on this. Okay. And then let's do some like one erosion maybe, a couple dilations. All right, so now I can bring this a little bit closer. Let's bring it farther. Yeah, it's like pointing the laser at my hand a little bit. Bring it up. So the image processing is there. Which is good. It's okay. Oh yeah, and then the current is about 0.5 amp to do this. And if let's say if I like really move it, let me see what you guys are saying. Okay, if I move this, right, I try to knock it off its balance, right? PADs could probably need a little bit of work. So the jitteriness that you're seeing is attributed to the fact that I probably need to tune the PADs a little bit more, but more importantly, that rocking is because I don't have a high enough resolution on the encoder. So that's why I need to replace the Hall sensors that are inside of these things with more higher resolution encoders. Preferably absolute encoders, which I do plan on doing. Not in this video though, that'd take a lot longer. I'll probably do it in the next video. But I consider this a success because I honestly, I haven't gotten to this point in like almost a year, maybe like half a year or a little bit longer. So I'm glad this still works, kind of. Could be better. And obviously this isn't a RoboDog yet. It's just the shoulder joint. And there's a lot more to figure out on this because these hoverboard motors are heavy. I don't know if it's going to be able to support its own weight. There might be some work that we need to do there. I might not have all the joints be hoverboard motors in this quadruped. think that'd be too heavy. I'll figure it out later though. Cool. And if I turn off the client, right, this should still track, right? So it's still going. Let me bring up what the Zybo board console is saying. Okay, so we bring that in. Okay. It should still track. Well, it's definitely still doing something. Pointing at it, sorta. Cool. I'll kill this. There it goes. Cool, not bad. Turn this off. There it goes. I'm just kind of like looking through the code just so that I can remember stuff that I was doing here. Yeah, this is the video capture thread. Class. Some checks here. Make sure it doesn't go over a certain angle. Data that I'm sending across the socket. Processing stuff. This is where the start of the thread is happening. Those are the ports. The interfacing with O drive. I also, from here, should be able to access O drive, right? Is it just O drive? I forget what the... It might be useful to know what the command is. Oh, I think it's ODrive tool. ODrive tool, right? Yeah, okay. So I'm connected to ODrive right now. I think if I just type in ODrive, is it just ODrive 0? Yeah, okay. So this is like all the information, not all, but a lot of the information that's in ODrive. And by the way, like the people who made ODrive, this is actually a pretty old version now. They have more compact ones, which I'll probably get eventually. Just I haven't done this project in a while, but I'll probably upgrade. I can't imagine it's too different from what I'm looking at here. But you can see all sorts of information here, and there's the ability to be able to control the motors individually through here. This is actually a pretty slick setup. It's done through Python. And if you want to get like access 0 information, right? Like this is access 0, so that's motor 0. So this is like all sorts of information, like motor characteristics, what your input position is, where it actually is, what the torque is, what voltage you're supplying to it. It's doing a lot for me. So yeah, I could keep going down this rabbit hole and look into this, but I think this is where I wanted to be so far with this video. I don't want it as long as I did the last live stream, which was like 5 or 6 hours. So I think this is a nice, short, sweet, simple video just to show this getting working again, and the current state of things in this setup. So I think I'm actually going to end it here. Next video, I'll go down more down this rabbit hole and probably do more stuff with these encoders. Yeah, like I was saying, there's Hall effect sensors in here. They're not very accurate. So I need to find out a way how to use this. So honestly, I'm just thinking about this now. I'll probably use the next live stream, which will probably be next weekend, to just figure out how to use these. I mean, at the end of the day, the thing that's ingesting the encoder values is O drive here. It's what's sort of the brains for the motor control. And then the Zybo board is obviously connected to this, telling it what to do. But I need to make sure that, one, I understand how this works, and I'll do some soldering in the next video, connect headers onto this, and mess around with it. I don't know if I'm going to use an Arduino or just something just to get like any sort of signals out of it. But something that I kind of want to do in the next video is, if I hook this up somewhere and I'm turning the hoverboard motors, is that going to interfere with the signals on here? Because it is receiving, like how this works is you have a magnet that's fixed on the motors. And as the motors turn, the magnet turns, and then this chip is actually needs to be pretty close to the magnet. And then it senses the change in magnetic fields as you turn the hoverboard motor. I'm just super concerned that there's large coils. I mean, it's a brushless DC motor, and there's large coils in here. And I think once you're moving back and forth and switching frequently, it's actually going to mess up these readings and make things a lot worse. I don't know. I'll have to mess around with it. We'll see. Anyways, thanks everyone. Appreciate you tuning in. I need to switch everything back to the other side. Bye.